Hello, today we're going to look at how to factor quadratic trinomials. And to start, we're going to look at a monic quadratic trinomial. And that just means that the leading coefficient, that is the coefficient of the term with degree 2, this x squared, is 1. The leading coefficient is 1. That's all that monic means. Now, factoring is just the opposite of, well, expanding. So here's the idea. We're going to look at just the factored version, and we're going to work backward after we expand it. So let's say that this quadratic trinomial is nothing more than x plus alpha times x plus beta. It's just the product of these two binomials. The reason it's so hard to factor this is because it's hard to see what the original two binomials were. Anyway, as you can see, we have x plus alpha times x plus beta. Expanding, remember, we multiply by each term, so we have x squared plus beta x, and then we're going to distribute this alpha. So alpha times x is just alpha x, and alpha times beta, I hope you can agree that it's just alpha beta. Alright, and now, in fact, I'm going to group like terms, collect like terms, and you'll see that this is just x squared plus, and in brackets, we have the sum of the coefficients. Let's say alpha was 2, beta was 3, you'd have 5x. And in the same way, this is just going to be alpha plus beta x. I hope you can see how that works out. And if you distribute the x, of course, you get back to the original expression. Now, last of all, we have alpha, beta. And this is what we'll notice. Right here, we have alpha, beta. Alpha plus beta as the coefficient of x. Up here, p is the coefficient of x. So we can say that p is just alpha plus beta. Or maybe we look at it the other way, alpha plus beta equals p. And similarly, alpha times beta is q. And here's the idea. You just need to find two numbers that satisfy this condition. So we need two numbers, alpha and beta, that add to give you the coefficient of the middle term. And we need two numbers, the same two numbers, to have a product that is just the constant term. Now we're going to look at an example. Here we have x squared minus 3x minus 4, and of course this is monic. The leading coefficient is 1, so we can use our technique from before. So we just need to remember that x squared plus px plus q is just going to be x plus alpha times x plus beta, as long as the sum of those two numbers is the middle coefficient and the product of them is the last one. So coming back here, we want two numbers that multiply and give us negative 4, but add and give us negative 3. So what two numbers multiply and give me negative 4? What about negative 2 and positive 2? Does this work? The answer is no. Although they multiply to give us negative 4, they add to give us 0, not negative 3. So I'm going to try another one. I'm going to try negative 1 and positive 4. And we'll see if that works. I multiply, I get negative 4. That's good. I add them, but I get positive 3. That is not good. We have a negative 3 here for the coefficient. And here's the correct combination. It's actually going to be negative 4 and positive 1. You multiply them, you get negative 4. You add them, you get negative 3. So now we can just plug it into our formula. It's just x plus 1 and x minus 4. And you'll see if you expand it, you do indeed get back up here. Now, there's just one problem. What if the leading coefficient a is not equal to 1, and it's not monic, and we can't use our technique right here? We can't just find the two numbers. Now, here's the technique I'm going to show you. In fact, we're just going to reduce it to that form. We're going to make it so the leading coefficient is 1. Now, here's one way to do it, and I don't think it's very effective when you're working with integers, because it'd be very hard to find the roots. Now, consider 4x squared minus 5x minus 6. What I'm going to do is just divide everything by 4. So divide by 4, divide by 4, divide by 4. But that changes the value, so I have to multiply everything by 4 as well. And now I can pretend like nothing happened at all. This is the exact same expression. And now we have the 4 on the outside multiplied by 4 over 4 is just x squared. And notice the leading coefficient here is 1. Now we have minus 5 over 4x. And finally, minus, I'll simplify this, 3 over 2. And there we go. Inside, we just have a monic quadratic trinomial. But this is really hard to factor, right? We're not working with integers. I'm supposed to find two numbers with a product of negative 3/2 and add up to negative 5/4, 5/4. This is actually very hard. So I'm going to show you a better way to reduce it to the monic form. Now, we're going to come over here and we're going to say ax squared plus bx plus c is nothing more than a times ax squared plus bx plus c. That's not quite right, because you see if we multiply everything by a, something changes. A is not 1, of course. It's not going to be the exact same expression. So at the start, we're actually going to divide by a as well, multiply by 1 over a. And now you see, no matter how you want to simplify this, you're going to get back here. These are equivalent expressions. We've just multiplied by 1. Now, I'm only going to distribute this a. We're going to leave the 1 over a on the outside, and you'll see why. So distributing the a, I multiply by the first, second, and third terms. Every term inside. That is just the distributive property at work. So now we have 1 over a, and on the inside, I multiply and I get a squared x squared. And now I have a bx, and then ac. There we go. It might look a little crazy. Why would I do this? This looks so much more difficult than ax squared plus bx plus c. But in fact, I'm going to make a substitution. And I'll just rewrite this so you can see what's going to happen. 1 over a multiplied by, we have a squared times x squared. And by the exponent laws, we can just rewrite this as ax in brackets raised to the second power. By exponent laws, that just goes back to being a squared times x squared. And over here, abx, I'm going to group the ax together as well. This is b times ax. And finally, of course, we just have plus ac. And I'm going to make this substitution. T is equal to ax. You'll see where this is going now. This is just 1 over a on the outside multiplied by t, because that's ax, raised to the second power, plus bt, and finally, plus ac. And what do we notice? You see, this is just a quadratic trinomial. The leading coefficient is 1. And if we started with integers, b is still an integer, and the product of two integers is also an integer. This is a very nice way to reduce it, and it's better than this one because you definitely don't need to deal with rational numbers now if you were originally dealing with integers. So now we're going to apply our technique. We have a non-monic quadratic trinomial now. And remember, we're going to multiply by 1. But 1 is just 4 times 1/4, or 1/4 times 4. So I'll have 1/4. Then I multiply everything on the inside by 4. So 4 times 4x squared is just 16x squared. And then minus 20x minus 24. And these are equivalent. If you distribute, you get back to the original expression. Now remember, when we're reducing to a monic quadratic trinomial, in fact, we're going to make a substitution. And I'm going to show you where we find that substitution. We first need to group the ax. And in this case, ax is 4x. So this is just 4x raised to the second power minus 5 times 4x. And at the end, we actually still have minus 24. There's nothing to factor out there. And we're going to make the substitution t is equal to 4x. So now we have 1/4. On the inside, 4x is replaced by t, so we have t squared minus 5t, and at the end, minus 24. And look at that. That's just a monic quadratic trinomial. And the nice thing about this method is that we start with integer coefficients, and we still have integer coefficients. We don't need to deal with rational numbers, rational non-integer numbers. And our factoring technique, of course, we're going to need to find two numbers that add to give us our middle term, or middle coefficient, and they multiply to give us our constant term. So, let's test some numbers. Two numbers that multiply to give me negative 24 and add to give me negative 5. I'm going to try negative 6 and positive 4. Do these work? No. Although they multiply to give us negative 24, you add them and you get negative 2. I'm going to tell you that the correct combination is actually negative 8 and 3. You multiply them, you get negative 24. You add them, and you get negative 5. This is all good. So, we can finally rewrite it using our formula. We just have t plus the first number, alpha, and then multiplied by another binomial, t plus the second number, beta. So, we found the two numbers, negative 8 and positive 3. We can just plug them in, and we're all done. Right? Not yet. Our original expression is in terms of x, so our final answer should also be in terms of x. But remember, t is nothing more than 4x. We can undo the substitution right away. So we have 1/4, 4x minus 8, and finally 4x plus 3. And the nice thing here, we can actually simplify. If you factor out a 4, we end up with a 4 on the outside, right? And then x minus 2. And 4 over 4 is nothing more than 1. And there we have it. That's a technique that just involves reducing to a monic quadratic trinomial. And I like this better than splitting the middle term and factoring by grouping, because when you get really good, you can skip straight to this step with simplified. And that means you don't need to do factor by grouping, you don't need to split the middle term. It's very quick, very easy, and it just relies on knowing how to factor a monic quadratic trinomial.